A galaxy will collide with ours. Andromeda, the largest galaxy in our cosmic neighborhood, is hurtling toward us at a staggering 400,000 kilometers per hour. The collision is unavoidable, so the real question is, what exactly is going to happen? Will they crash into each other like two billiard balls and bounce off? Will they instantly fuse? And more importantly, what will happen to us? Will Earth be destroyed in the process? Surprisingly, none of those things will happen. But let's take a step back and properly introduce the main characters of this cosmic event. On a very clear night, if you look up into the sky, you can actually see both galaxies without a telescope. On one side, there's the Milky Way, the galaxy we call home. And on the other, that tiny fuzzy patch in the sky, the bright core of Andromeda. Even though it looks small, Andromeda is a galactic titan. Its mass is roughly 10 times greater than the Milky Way's. It appears so tiny to us simply because it's incredibly far away, about 2 million light-years from Earth. If intelligent beings existed in Andromeda and could observe our planet, they would probably see a bunch of weird primates doing funny things. Anyway, the reason Andromeda is coming toward us is nothing exotic. It's the most natural thing in the universe: gravity. In our local group of galaxies, Andromeda and the Milky Way are the two largest members. And mass attracts mass. So the two are inevitably being pulled toward each other. The gravitational pull is so strong that not even the universe's expansion can stop this galactic encounter. Unlike what happens with most other galaxies drifting apart, these two are locked in a gravitational dance. So how exactly will this collision unfold? Even though Andromeda is moving incredibly fast, it's still nothing compared to the massive distance it needs to travel. 2 million light-years is no joke. So this journey will be slow. Painfully slow. We're talking about billions of years. If we could somehow speed up time and watch this approach unfold naturally, we'd see Andromeda inch closer at a speed comparable to the drift of Earth's tectonic plates. Yes, that slow. Over the course of millennia, Andromeda will appear just slightly larger in our night sky. Then, after about 1 billion years, it will look like a bright glowing disk above our heads, but so far, we still wouldn't notice much of a difference in our lives. Now let's jump ahead. 2 billion years from today, Andromeda will finally reach the closest point to the Milky Way in its entire history. The night sky will be dominated by Andromeda and its satellite galaxies. A breathtaking view, but it won't last. Because these galaxies have been accelerating toward each other for billions of years, all thanks to gravity. So when they meet, they'll pass through each other at 1.5 million kilometers per hour. Yes, through each other. You see, a galaxy is essentially a vast collection of stars, gas, dust, and dark matter held together by gravity. Even though the Milky Way contains hundreds of billions of stars, they're separated by enormous distances. It's like two armies charging at each other, but with each soldier spaced 30,000 kilometers apart. That's about 3 Earths of distance between every 2 stars. So, when the galaxies collide, most stars will simply pass right through without any direct interaction. There's just too much empty space. That said, the dense clouds of gas and dust will interact. These materials will be compressed and stirred up during the encounter, triggering massive waves of star formation, a cosmic baby boom. While direct stellar collisions are unlikely, the gravitational interaction between the galaxies will still cause massive distortions. The Milky Way's beautiful spiral structure will be disrupted. A long tidal tail of stars and gas will stretch out from our galaxy, a distorted extension created by Andromeda's gravitational pull. This strange galactic stretching will unfold slowly. Andromeda will remain merged with the Milky Way for millions of years. Now, let's talk about Earth's fate during all this. No, we're not likely to crash into another star. That's incredibly improbable. But we could get flung out of place. It's possible that the Sun, and us along with it, could end up in this newly formed tail. We might get relocated to a completely different region of the new galaxy. Some estimates say there's a 12% chance of that happening. And there's even a 2.7% chance that the Sun could be captured by Andromeda completely. Meaning Earth would become part of a new galactic neighborhood. Imagine looking up and seeing Andromeda grow huge. Then overlap with the Milky Way. And then, gradually, watch the Milky Way shrink in the opposite direction. A cosmic game of tag across the sky. Of course, that comes with risks. Some parts of our galaxy are extremely active and dangerous for a life-harboring planet like Earth. But then again, the solar system already makes a full orbit around the Milky Way every 200 million years. So perhaps galactic displacement is inevitable in the long run. But the story doesn't end there. After their first pass, the galaxies won't simply merge right away. Instead, they'll drift apart again, up to 1 million light-years away. Gravity will slow them down. And eventually pull them back toward each other. 3 billion years from now, they'll approach once more. It'll be similar to the first time. A small point of light in the sky slowly grows larger. Until we can see its full detail again. But this time, their separation will be less dramatic. They'll only pull away by 170,000 light-years before gravity calls them back. With each encounter, they lose energy. Through interactions with gas, stars, and dark matter, the galaxies experience a kind of gravitational drag. A cosmic friction that slowly drains their momentum. This means the merger speeds up each time. On their final encounter, 5 billion years from now, the two galaxies will finally fuse into one. Their supermassive black holes will begin orbiting each other, creating powerful gravitational waves. Eventually, they'll merge too, releasing more energy than 1 billion suns emit in an entire year. A true ripple in the fabric of space-time. But don't worry, that won't really affect Earth either. So that's the end of the story. Andromeda and the Milky Way are gone. A brand new galaxy has taken their place, irregular in shape and structure. We call it Milkdromeda. But what about us? As you've seen, we probably won't be around to witness any of it. It's like waiting for a mountain to move, or worse. In fact, over the next 2 billion years leading up to that first encounter, Earth's tectonic plates will shift dramatically. Continents will change places. Land masses could circle the planet 10 times over. And that brings us to a more immediate concern. The age of our sun. As it ages, it gets hotter. In a few billion years, Earth may no longer be habitable. So we may not be here to see any of these galactic fireworks. But who knows? Maybe our distant descendants, armed with unimaginable technology, will witness it all. Just another one of the universe's many inevitable drifts. Thanks for watching, and if you're enjoying this cosmic journey, don't forget to like the video and subscribe for more mind-blowing science every week. We'll see you very soon. With just a little more science.